Hello class, this is a video tutorial on using inverse trigonometry ratios to determine size of angles. So in this video we're going to learn to determine first the correct trig ratio from the given information. Then we're going to learn how to use inverse trig ratios. And lastly we're going to learn how to do two more things: round angles to the nearest degree and to the nearest minutes. Okay, let's begin. Here we go. So I'm going to be using this as our first example, and after that you can pause the video and give it a go for these three. Okay, so firstly we need to determine the correct trig ratio from the information that we have. Well, from this triangle and from this angle, also notice how in this angle it's not given to us. There is not an angle there. It's a symbol called theta, and with these ones, A degrees, Q degrees, and X degrees. And so we need to figure out what that angle is. In order to do that, we need to first figure out if it's sine, cos, or tan from this information. Well, from our angle, we have opposite, and we have the hypotenuse. So opposite and hypotenuse, that would be sine. But it can't remain blank, it has to be sine of theta, like that. To get that value, we get sine theta is equal to opposite over hypotenuse, which is 3 over 5. We can simplify 3 over 5, okay, as, well, if we can do it, let's see if we get a neat decimal. So how I did that was I took 3 over 5 and I pressed this button, which gave us 0.6. So we have sine theta is equal to 0.6. Now at this point, here's how we transfer and use inverse sine to solve for the value of theta. It's going to look a little bit weird, but bear with me. So it would now become theta is equal to sine inverse. So sine with the index of -1 of 0.6. And now this is the value that we will be using. Okay, here we go. We'll get, this is the value that we're going to type in here. In order to get this symbol, if you look very carefully here on your calculators, you'll see that it has sine, well, above sine you have that sine with -1. We need to be using that function. To get there, we press shift and the sine to get that sine with a -1. That is inverse sine of 0.6. Although it gives us as a decimal, we want the values to be as degrees, minutes, and seconds. Now I'm going to round this first to the nearest minute. So blocking off here, those are the values I would like to write. Alright, there might be some rounding here. If ever this value here becomes 30 degrees or more, we round this value up by 1. I'll show you what I mean in a moment. So to the nearest minute we get 36 degrees, 52 minutes. We have to indicate that is to the nearest minute. We have rounded to the nearest minute, min. But if we round to the nearest degree, the only values we'll be looking for are these ones here. So it'll be 36 degrees. However, just like I said, we look at the previous value, and if this minute section ever exceeds 30 degrees, we have to round this up by 1. So since 52 has gone past 30 minutes, this will become 37 degrees. That is to the nearest degree. Nearest degree. Now, I'd like for you to give this a go on these 3 examples, because I'll be answering them very quickly in 3 seconds. 3, 2, 1, and here we go. Once again, we need to figure out whether or not which ratio we have to use. So from A, we are given the opposite, and 18.5 is adjacent. That is tan. So we have tan of A degrees is equal to opposite, which is 15 over 18.5. We can evaluate 15 over 18.5. So 15 over 18.5 will give us, well, I'm going to leave it like this as a meter fraction. Okay. Whichever is the neatest for you. So we get 30 over 37. Tan A. Then we take the inverse of this. So we take A degrees is now equal to tan inverse of that value we just discovered, which was 30 degrees, 37 minutes. I'm going to continue up top here. We're going to input this value into our calculator. So we take shift tan fraction 30 degrees 37 minutes, close our fraction. That'll give us, we need to convert this using our bubble button here, or DMS button, degrees, minutes, seconds. Let's first round this. So A degrees is equal to, let's do it both. We get 39 degrees 2 minutes. That is nearest minutes. Or we can round this to the nearest degree, which is, 2 degrees is not past 30, so it is just 39 degrees. That is to the nearest degree. Moving right along. Once again, from our information, we have, from our angle, we have opposites, and we have the hypotenuse, h. This will give us, let me see here, we have, that's sine, we have sine of q is equal to 13.75 over 20.5. I'm going to show you a little trick here that we can skip right to the inverse. I'm going to keep this as it is and inverse it straight away. So Q is now equal to sine inverse of the value that we have here, which is 13.75 over 20.5. Inputting this value, we get shift sine fraction 13.75 over 20.5. Converting this, we get 42 degrees 7 minutes. Let's do it again to the nearest minutes. 42 degrees. Since 24 does not exceed 30, it remains as 7 minutes. So that is 7 minutes. We must always indicate that is to the nearest minute. Let's round it one more time to the nearest degree. So focusing just on the degrees, 7 does not exceed 30, so this remains as 42 degrees as nearest degree. Solving our last question here. Once again, from our angle, we are given the adjacent, and we are given the hypotenuse. This one here is cos. So we now have cos of x degrees is equal to 20.7 over 32. We take the x degrees is equal to cos inverse 20.7 over 32. Inputting what we have here, cos inverse fraction 20.7 over 32. This will give us, once again, this button here. That gives us, let's round to the nearest minute first. So our minutes is here with that single. Since 36 is past 30, the 41 becomes 42, so it becomes 49 degrees, 42 minutes. Nearest minute. And rounding it to the nearest degree, well, 49 degrees, because 41 is past 30, we have to round this one up. This becomes 50 degrees to the nearest degree. Hope that gave you good insight into how to solve the size of angles using inverse trigonometry. Best of luck!